Dear students, welcome back to the chapter Triangles. In period 29, we have seen the congruence of triangles and the rules when we say that two triangles are congruent. Two triangles are congruent when three angles of a triangle is the same as three angles of the other triangle. That is condition number one. And condition two is all the three sides of one triangle is the same as the three sides of the other triangle, which means we have seen 6 conditions are satisfied, then the triangles are congruent. But there are 4 criterions or 4 rules which says if we follow only 3 parts of 2 triangles are the same, then they are congruent. Let us briefly see what are the rules here. The 4 criterions are, first one is SAS, next one is ASA, next is SSS, and the last one is RHS. From the words, from the abbreviations, they are clear. SAS, 2 sides and the angle in between. The next one is ASA, 2 angles and the side in between. Here, 3 sides and the right triangle with hypotenuse and side. Let us see one by one. The first one is SAS. SAS congruence rule says that 2 triangles are congruent if 2 sides and the included angle of one triangle are equal to 2 sides and included angle of the other triangle. Let us see with an example. Here we have 2 triangles PQR and STU. These 2 triangles are congruent if 2 sides, let us take the side PQ is the same as ST and QR is also same as TU. So we have 2 sides. And the included angle, included means it should be in between, which is here it should be Q and it should be T. It can't be P or R because if you take P, it is not between the given sides. So included means we have to take the angle which is between the 2 given sides. So here, if this angle is, let's say, 65 degree and this is also 65 degree, then we say that these 2 triangles are congruent. And we have seen how to write congruence. First triangle can be written in any way, P, Q, R. And the symbol of congruence is this way, is congruent to PQ is the same as ST. So we have to start with ST and the last side is QR, which is TU. So T should continue with this. So these 2 triangles are congruent by which rule? It is SAS. Remember, 2 sides and the included angle. What if you take the angle between the 2 given sides as a different situation? For example, these 2 sides are given and angle P is the same as angle S. Now, this is not enough to say that these 2 triangles are congruent. We can't say that they are congruent. So, not congruent. Now, let us see another example. If side PR is the same as side SU and side PQ is the same as side ST, which angle should be given to show that these 2 triangles are congruent? Can it be Q and T? No, because this is not in between the given sides. The given sides are PQ and PR. So the angle between is P. So it should definitely be given what is P. Let us say P is 50 degree and S is also 50 degree. Yes, then these 2 triangles are congruent by SAS. Side, angle, side. So 2 triangles are congruent under SAS congruence rule if 2 sides and the included angle of both the triangles are same. Let us move to an example. OA is equal to OB. OA is equal to OB, which means these two are equal. And OD is equal to OC. OD, let us mark it by 2 slash. These two sides are equal. Now we have to prove that AOD is congruent to BOC. AOD is congruent to BOC. Now we have two sides. So let us take the sides which are equal. So BAO is congruent to, equal or congruent is the same, OB, it is given. If two lines are intersected, we studied that vertically opposite angles are equal. So we can say angle AOD is congruent to angle BOC because they are vertically opposite angle or simply vertical angles. So here there is a side, we get a side, and here we get an angle. Next, we also have another side DO is congruent to side CO, it is given. So we have another side. So we can say by SAS triangle AOD is congruent to triangle BOC. Now we have to show that AD is parallel to BC. For that, we have to follow what is CPCT, corresponding parts of congruent triangles. AD is parallel to BC if they follow either corresponding angles or alternate angle or same side interior. Let us take the Z shape here. Here we have a Z shape. Now let us see what is angle A and angle B. We have angle A is the first letter, so angle A is congruent to angle B. How? By CPCT. By CPCT, angle A is congruent to angle B, so we can say that line or line segment AD is parallel to BC because alternate interior angles are equal. Let's move on to another example. AB is a line segment and line L is perpendicular. What's the meaning of perpendicular? Line L, this is the line L, which is perpendicular to the line segment AB. And that is also a bisector. Bisector means cut into two equal parts. So AC and CB are same. Bisector means cut into two equal parts. So we get that in the triangle ACP and the triangle PCB, we have CB is equal to AC. So let us write down AC is congruent to BC because they are bisected. Now, angle ACP, this is 90 degree because it is perpendicular. So we can say angle ACP is congruent to angle BCP because both are perpendicular or 90 degree. Now, PC, look at the side PC. PC is a side of the white triangle and PC is also a side for the purple triangle. So it's the same measurement. If PC is 8 centimeters, both of them have the same measurement. So we can say PC is congruent to PC or they are the same. So why? Because it is a common side. So here we get a side, here we get an angle, and again we get a side. So by SAS criterion, triangle ACP is congruent to triangle BCP. Now the question is to show that P is equidistant from A and B. Means the distance from here, these two sides are equal. This is what you have to show. Now look at this congruence AP. Look at the congruence AP, first and last letter. It should be congruent to BP. So by congruence, we can say AP is congruent to BP. Why? Corresponding parts of congruent triangles. AP is congruent to BP, which means the distance are the same. Or we can say, so P is equidistant from A and B. That's what we have to prove. Great. Let's move on to the second criteria, which is called ASA. ASA means two angles and the included side of each triangle are same, then they are congruent. Two triangles are congruent if two angles and the included side of one triangle is equal to the two angles and the included side of the other triangle. With the shape, with the figure, if you study, it will be easy to understand. Two angles, let us say this is 80 degree and this is 40 degree. Same here, 80 degree and 40 degree. And these sides are given equal. So let us read it again. Two angles and the included side. Two angles and the included side, which is in between, not the second side or the third side, of one triangle is the same as two angles and the included side of the other triangle. Then these two triangles are congruent. So we can say triangle CDE is congruent to triangle C is the same as FGH. By which rule? By ASA congruence. So once again, we have to be careful. If two angles are given, the included side is also given equal, then they are congruent. But here, they might ask you a tricky question. If this is 80 degree, and nothing is given about here, and this is 60 degree. And here again, they give you 80 degree, and this is 40 degree. These two sides are equal. Are these two triangles congruent? I would say it is congruent because when you apply the angle sum property of a triangle, you know that this is 80, this is 60. So this is total give you 140. Plus what angle will give you 180? Yes. So we can find what is the missing angle. Now this is the same as example that we did just before. So one angle, angle D, is the same as angle G. Both of them are 80. Again, we have the side DE is congruent to side GH. Given they are equal. Again, we have side or angle E is congruent to angle H. It is also given, or which is 40 degree. So we have angle, side, angle. So by ASA, these two triangles are congruent. Triangle CDE is congruent to triangle FGH. In the next period, we will complete the exercise 7.1. So thank you for watching and see you later.